Good evening everyone and welcome to the Q&A session 26 from the playlist of electrostatic potential and capacitance. The topic is the calculation of the variation or the change in the electric potential inside a uniformly charged non-conducting solid sphere when the medium is changed. So based on this topic, I have framed one question for this session, and the question is find the change in electric potential due to a uniformly charged non-conducting solid sphere of radius capital R at its center when it is immersed in water. So initially the solid sphere is lying in free space. So in the session number 24 we have learned or we have derived the equation for the electric potential inside a non-conducting solid sphere, which was given by the formula Q V is equal to Q divided by 4 pi epsilon naught R in bracket 3 capital R square minus small r square divided by 2 capital R square. So this is the formula which is applicable when the medium is free space or air. But here, so when the solid sphere is in free space or air, then the potential, say it is V A, or we can simply write as V air. This will be equal to, here R will be equal to 0 because R is the distance of any point from the center of the solid sphere. So here in the case when we have to find the change in the electric potential at the center of a solid sphere, then in that case small r will be equal to 0. So the potential at the center of a solid sphere or not a non-conducting solid sphere when the medium is free space, this will be equal to, say it is V air is equal to Q, small r will be equal to 0. So I will be getting the equation as 3Q divided by 8 pi epsilon naught R. So this is the potential at the center of a non-conducting solid sphere when the medium is free space. And when the medium is water, so let us say the potential at the center is designated here as V water. So V water, this is equal to Q divided by 4 pi. Now since the medium is water, so here epsilon naught will be replaced by epsilon. So and epsilon is equal to is the permittivity of a medium, and this is equal to epsilon naught into epsilon R. So if I just substitute this value, so this equation will be equal to 4 pi epsilon naught epsilon R into R, and in bracket it will be equal to 3 capital R square divided by 2 capital R square. So this will be, so V, that is the potential at the center of a non-conducting solid sphere when it is immersed in water. This is equal to, this will be equal to, this is this R square and R square will get cancelled out. So I will be getting 3Q divided by 4 pi epsilon naught R into epsilon R. Now epsilon R is the relative permittivity of water. The value of the relative permittivity of water is equal to 81. So here the potential at the center will become equal to 3Q divided by 4 pi epsilon naught R into 1 by 81. So the potential at the center of this solid sphere when the medium was air is equal to 3Q divided by 8 pi epsilon naught R, and the potential at the center when the medium is water is equal to 3Q divided by 4 pi epsilon naught R into 1 upon 81. So from here we can say that the potential at the center when the medium is water, this is equal to the potential at the center of the solid sphere when the medium is air divided by 81. So we can here see that the potential at the center of a solid non-conducting sphere is getting reduced by a factor of 81 when it is immersed in water in comparison to the electric potential when the solid sphere was placed in free space or air. So from here we can see that the electric potential at the center of the solid sphere has decreased when it was immersed in water. So in the next session now I will be discussing a different type of a question from the same topic of this electric potential inside a uniformly charged non-conducting solid sphere. So till then, have a nice day. Bye.